Hey, what's up, guys? Chung here. Uh, so this time, let's continue our tree journey on LeetCode. And so we're gonna talk about this number 1008, right? So construct binary search tree from pre-order traverse, right? So what this? So you're given like a pre-order array coming from traversing the tree. So basically, as for example, this one, right? So you do a pre-order traverse 8, 5, 1, right? And then pre-order is the left. I'm sorry, pre-order is the root, left, and right, right? Root, 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 left, and then right, 7, right? And then 10, 12, right? So you're given a pre-order traverse array, and then you're asked to construct a binary tree based on this pre-order traverse array, right? So so how should we do it, right? I mean, so I think it's obvious that we need to get the node one by one, right? So basically first we get node 8, right? So for pre-order, the first one is the first one will be the root node, right? And then we check the second array on the second element in this array, which is 5, right? So the 5 will be we check how where we should put it, right? Should we put it onto the left of the 8 or right of the root, right? So how can we check that, right? I mean, and then we just keep going down the way, right? So we just do it recursively, right? So we do 5 and then we just pass it down here, and we do 1, we do 7, right? And we do 10, right? How sh so it's a recursive idea here. So usually when we construct a binary tree, we can create the helper functions, and then we pass the lower bound and an upper bound, right? So basically, we only and every time when we see a node, we cut the bound into two half, right? So into this side and that side, this side, into that and that side. Like this is a lower, this is high, right? And when we see a new node, we use the level, we use the value on this node, and we cut it to the left side and right side. And then with this range here, so we only pick the next number, right? We only pick the next number when the number is within the current range. Otherwise, we just skip. For example here, right? So let's say with 8, so we initialize the lower bound, higher bound with the smallest number and the biggest number, right? And then we go to left, right? The left side will be lower bound and plus the to the 8 here, right? We see, and then we check, oh, 5 is the okay, 5 is in the range, and then we just get 5, and then we'll move this index forward to 1, right? And then we see left and right, right? So we have another left and right here. When we see the left here, because we have left first and then right. So when we see 1, okay, 1 is also in the left side, so we place 1, right? And then it's done, right? So 1 is so 1 is the end. 1 is the end of the node. And then we check, right? So with 1 in the end, we still need to cut it into half, right? On the left side and right side. So the right side is bounded at 5 right here, right? It's 5 and then 5 here. And the next one will be uh 7, right? So still we check left and right. If the left side is has the if the 7 is in the left side, no, it's not. Is it in the right side? No, it's not, right? Because the 7 is even bigger than the upper bound. So this left and right, it will both return now. right? And our index is still pointing to 7, and then goes back here, check on this side, right? Is 7 on this side? Yes, it is, right? Because on this side, it's bounded at 5 to 8, right? To 8 here. And 7 is within this range. So every time when we see the current node, the current index value is within the range, and then we just move the cursor forward. And we just keep going, 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 because once this 7 is finished, right? And the next is 10, right? And then we check and this recursion is done, right? So 7 is done, and we will continue with 7, right? And the next one will be 7's left and right, right? So 7's left at 10 is obviously not within any of the range here. So it will both return none, none, and then we keep going back to, we'll go back to 8 here, and then we go to right side, and so on and so forth, right? In the end, we'll have this complete binary tree. Okay, so we're gonna have a helper function here, like we said, and this helper function will have like a lower bound and higher bound, right? I'll just use it low and high here, and we also need to create like define a global index here. I mean, we can also every time we can just pop these things from the left side, but I think we're just using index to avoid modifying the parameters here. And then so here basically we just return the helper functions here, right? So we have to initialize it to the max size and yeah. So okay, so first, what do we check here, right? Right. So if the index, right? If the index is, we can also do like a length here of the preorder, because we want to know when we have traversed all all the elements in the array, right? So if index is equals to the n here, right? Then we know we already process all the nodes. Why not n minus one? Because n minus one is the last node, right? We still want to continue here, right? So return return none, right? But basically we just stop, right? And then like what we discussed, we'll get the current value, right? So the current value, what's the current value? That's the pre-order array with the current index, right? That's the current value we have, and we check if the current value is not if it's not in the range, right? So basically, if the current value is smaller than the lower bound, or current value is greater than the upper bound, right? And then we know it's not a valid one. We just simply return, right? We return none here, because that means on this side, left and right side, we assign none for both, right? So it is in the range, right? We just do a basically we just do another check. We just um, we'll create a node here with the current value here, right? Because then we know we can use this value to create a tree node here, and the current value, right? And then we know, since we already use this one, the current values, to create a node, we need to increase the index by 1 here. And then we just uh, do it recursively, right? And node helper, right? So lower current value, right? Current value goes to high, right? And in the end, we simply return the node here, which is the current node. Okay, the local index here. Let's see. Why is empty? Yeah, I'm sorry here. Um, should be left and right, right? So basically, what we're doing here, we tried for both left side, we tried for both the left array or the right subtree, and with the updated bound here, just to see if we can place the next the next number in this pre-order array to the left side, right? And then if it is, we just stop, right? And then if it's not cannot be placed into the left side, and then we try the right side with the updated bound here, right? I mean, because if it's placed in here, right, then the next one it will be we'll try that node's left and right with the next node with the next number again, right? And then we just keep doing it until we have consumed all the number in this pre-order array, and then let's run it. Yeah, yeah. Okay, so it passed. So basically, so what we're doing here to recap what we discussed, we we use this lower bound and upper bound. So many times when we construct a binary tree, we always use this lower bound and upper bound because with this lower bound and upper bound, we basically we know, right? With the left side, we know we can only uh, use the node if that node is within this range, right? With the right subtree, we know that the same thing. We have to be each node has to be within this same range with this correct range here, right? If it's not in the range, we just simply do not pick anything from this array here, right? Basically, and then if it's a valid node, then we just create a tree node by using the next value, and then we just keep moving this. Then we already process the current one. We just move this index forward, and then we try all the possibilities for the left, for the right, right? And then we just keep doing it and until we reach the end of the array. All right, cool guys. Thank you for watching, and I think this gonna be no, I don't know if this is gonna be the last three videos or not, but I think I'm doing this like this is problems by the categories or by tags. I think I already done a few many tree problems, so I think most likely I'm gonna stop here. If not here, or maybe there's gonna be another one. So and then after that, I think I'm going to move to the graph. Yeah. Okay, cool guys. Thank you. All right, see you guys. Bye.